So this video is going to look at calculations with the mole associated with the smallest thing, which is particles. So mentioned this in the previous video when we were talking about the introduction of moles. We're going to call these representative particles. So 1 mole is equal to 6.02 times 10 to the 23rd representative particles. What exactly does that mean? Well, it depends upon what it is going to be what its particle name going to be. So if it's just a pure element, we're going to call the smallest thing their atom. Okay, so if I have iron, if I have copper, if I have lead, any of those elements, all of the elements off the periodic table, we're going to say the smallest thing that we're breaking everything down to is atoms. If we have what we call molecular compounds, those are going to be those non-metals on the right-hand side. We're going to call them molecules. And again, for this intensive purpose, water is considered a molecule. Carbon dioxide is considered a molecule. Again, that distinction is not going to be that critical for you right now, the difference between molecular compounds and ionics, but there is a difference. Ionic compounds is really where we're going to focus most of our energy in this course. So sodium chloride, again, calcium phosphate, anything that we've been writing formulas for, those are ionic compounds. And these are going to be called formula units. So atoms are going to be atoms, molecules are going to be abbreviated MOLEC, and you will see why in a second. Formula units, chuckle, chuckle, is going to be FU. So laugh all you want, we're going to call them FUs. So what does this mean in terms of the calculation? Well, that's what I'm going to teach you here in a second, but realize that a mole of any element is going to be equal to 6.02 times 10 to the 23rd. And in the previous videos, we did 1 mole is equal to so many grams off the periodic table. So this is always going to be the same. 1 mole of calcium chloride is 6.02 times 10 to the 23 formula units. Mole of CO2, 6.02 times 10 to the 23 molecules. A mole of anything is equal to 6.02 times 10 to the 23 particles. So what you're going to see in these problems is I'm going to use these 3 words where they are needed, but they all are going to do the same calculation. So the calculation is not going to be much different. And for this calculation, you do want to have some kind of calculator, because I'm going to show you a function on your calculator that's going to be very helpful for these calculations. So I am going to do what I call moles to representative particles first, and then I'm going to go backwards from particles to moles. So how many atoms are in 1.3 moles of potassium? So again, this is an atom because this is just pure potassium. And you will see once we do a couple examples here, it does not matter what it is for this calculation. So we're going to set up a proportion, okay? And we know that 1 mole of anything is going to be equal to 6.02 times 10 to the 23 atoms, okay? Or formula units or molecules. Okay, so I'll make this a little bigger so you can see it a little better. Sorry about that. So we're going to set up 2 proportions. Okay, the one on the left is going to be my standard, is always going to be what's given in the problem and what you're trying to find. And then over the right is going to be how, it's going to be the constant essentially. So how many atoms, so I'm going to put atoms on top, but it doesn't really matter, are in so many moles. And we're going to abbreviate a mole as an MOL. And yeah, you're going to say, really, that's not much of an abbreviation. We dropped the E for mole. But that is what you're going to see in most chemistry textbooks, is MOL is the abbreviation for a mole. So I want to know how many atoms, so that's my X, in 1.3 moles. So I'm going to write 1.3 on the bottom. So what do I know about atoms? Well, I know 6.02 times 10 to the 23rd atoms is equal to 1 mole. Okay, so we're going to cross multiply. Okay, and you're going to get the habit of this once you see a couple of these. So X is going to be equal to 6.02 times 10 to the 23 times 1.3. Well, I want you to use a special button on your calculator. You need to find the EE button. Okay, so find the EE button on your calculator. Okay, it's going to be useful for this very large number. Okay, and for this calculation, it'll work perfectly fine if you use like 10 carat to kind of get the power of 10. But I want to show you a much simpler method. Okay, so you're going to type in 1.3 times 6.02. Okay, then you're going to hit the second function key probably on your calculator. And you're going to hit the button that says EE, and E is going to appear in the screen. Okay, that's your power of 10. So all I have to do is type in 23. So I don't have to do times 10 to the caret 23. This is far more efficient, and you will find in the next calculation we're about to do, it's going to be important that you do it this way. So my answer is 7.8, and I have two sig figs here, times 10 to the 23rd. So you will see in the screen here, it says times 10 to the 23rd. Okay, now for this particular exercise, you will also see some calculators just do 7.8 E23. So that is another way you might see a calculator spit it out. But E in the language of the calculators means power of 10. All right, so how many formula units are in 2.6 moles of calcium chloride? Okay, so calcium chloride is a formula unit. Okay, so I'm going to change the vocabulary here. But one formula unit, 6.02 times 10 to the 23 formula units is the same as 1 mole. So this calculation is same, okay? So pause the video and see if you can come up with an answer for that. So again, same setup. X over the number of moles given is equal to 6.02 times 10 to the 23 over a mole, and you cross multiply. Again, in your calculator, okay, I'm going to clear out the calculator from this. So I'm going to take 2.6 times 6.02, second function E, so that the E appears. I hit, again, on this calculator, it is the blue key, so I hit that, and then I hit 23, and then I hit enter, and it will spit out the correct answer. So 1.56 times 10 to the 24th. Again, E24 might be what your calculator shows you. So last but not least, how many molecules are in 5.6 moles of SO2? So I'm going to pause this, same kind of idea. So again, these are molecules because SO2 is what we call a molecular compound. That's the only reason why. So again, you cross multiply, you should get around 3.4 times 10 to the 24th. And you will see I crossed this out because I only have 2 digits here. So my answer can only have 2 digits. 10 to the 24th, very important, molecule. So molecule is abbreviated MOLEC. Mole is abbreviated MOL. Okay, and that's where it gets very confusing very quickly. So your units are going to be very important when you're doing these types of problems. So you might not have to worry about that power of E, but when you do the backwards, when you do particles to moles, you have to use the proper function in your calculator. So how many moles are there in 2.05 times 10 to the 23 atoms of calcium? Okay, so again, I'm going to set it up this way. It doesn't matter how you set up these problems, what you put on top or what you put on the bottom, but just have to be consistent across both sides of the proportion. Okay, so what is given in the problem is the atoms. I do not know the moles, so that's your X now. 6.02 times 10 to the 23 atoms per 1 mole. So when you cross multiply, okay, you have 6.02 times 10 to the 23, 23, X is equal to 2.05 times 10 to the 23rd. So to get X by itself, you have to divide both sides by 6.02 times 10 to the 23rd. That's the only way you could mathematically do that. Well, this is where you have to use that E function. Or if you're using 10 caret, you're going to have to use parentheses because you will never, I repeat, you will never get the correct answer otherwise because the calculator does not understand your logic with 10 caret very easily. So type in 2.05, second function E, 23, hit division, okay, 6.02, second function E, 23, and then hit enter, okay? And you should get a reasonable number. So this is 0.341 moles, okay? Because I have 3 digits of significance here. This is power of 10, 23, power of 10, 23. So you're really just dividing 2.05 by 6.02, okay? So that number should be what it is. So why don't you try this one on your own, and I will come back and show you the answer. So 7.42 times 10 to the 24th, you're going to divide that by 6.02 times 10 to the 23rd, and you should get about 12.3 moles, again with 3 significant digits. So you're always dividing into that number. So again, It's going to be 7.42, okay? Second function E, 24, divided by 6.02, second function E, 23, and you will get 12.3 in your calculator. If you use the 10 caret, okay, if you type in 10 and do this caret thing and do 23 or something, the logic in the calculator does not understand that as well. So that is why your numbers do not come out correctly. So please be aware of that when you're doing these calculations.